Much, Kristen and Andrew. That was such a great intro to what we're going to be talking about. So we're going to be diving a little deeper into how researchers work with private companies, work with the cities to solve these problems in a way that protects privacy, that creates public good, and also advances research and creates more value for our partners. So I want to start off by everyone introducing themselves briefly, and then we'll hear a short presentation on some new research results that we are very happy to share with you. I'm Olivia Moore. I'm the Managing Director of the Center for Smart Streetscapes. Super excited to be here. I've been here since the launch of the center. I'm going to turn over to Mehmet to introduce himself.
Hello, everyone. I am Mehmet. I'm an Associate Research Scientist with CS3. I am a deep learning researcher focusing on generative AI, its theory, and its applications.
Hello. My name is Rob Holbrook. I work at the New York City Mayor's Office of Policy and Planning. My portfolio is accelerating the speed of government.
Hi, everybody. My name is Ahmed Darrat. I am the Chief Product Officer at INRIX. We're a transportation data company.
Okay, so Mehmet's going to get started with his presentation, and then we will turn it back to the panel discussion.
Let's see. Okay. So hello, everyone. Today, I will talk about our INRIX Plus Metro Lab Challenge research project on using flow-conserving physics-constrained graph neural networks to model and calibrate traffic observations throughout New York City. This was a lot of words, but what we are doing is fairly easy to understand. I press. I don't know the setup. Oh. Excellent. So this project spawned from work that we were conducting to deploy computer vision models at large scale for real-time situational awareness. I might need to click on those. Anyways, modern GPUs are extremely fast at processing footage from hundreds of cameras in real time, using today's real-time computer vision techniques accurately. And we were looking for useful applications of these capabilities to real-world problems. We used a network of 900 cameras across New York City over all 5 boroughs to collect vehicle counts in real time. And to the right, you can see what this type of system looks like in real time, but I don't think videos will play in this, unfortunately. So we will just skip past them. The announcement of congestion pricing coming into effect gave us something concrete to work on. We started doing this on the day the congestion pricing project was announced in November 2024, so that we could perform an in-depth year-to-year comparison. The methodology is simple. We count vehicles by time of week from every camera and look at what happened at the peaks from this weekly data, which is when congestion becomes visible to road users. Everyone can use their phones to actually access our main project website and look at all of these results interactively. I will give everyone a second to do so. Now, while working on the system, we learned about sorry, one second. Now, if you also access this live demo here that we have, you will be able to see in real time the output of our system. So this is what it looks like. Unfortunately, videos don't play here, so I won't be able to show you what this looks like in real time. But you can view our system change between cars, bikes, buses, trucks, and actually observe what this type of data collection looks like in real time. One second. Okay. So while we were working on the system, we learned about the INRIX Plus Metro Lab Challenge and signed up for it. INRIX provided us with traffic data, which consists of estimated volume per road segment by time of day, as well as detailed data about individual trips. When we are referring to trips in this context, a trip is a vehicle going from one place in the city to another. One limitation of today's traffic data providers is that observed volume collected from various GPS sources only provides a fraction of real-world traffic available. This becomes especially problematic for dense regions like Manhattan, where volume count through side streets, small side streets, might be really low in a given sample. On the left here, I am showing some sample data as a fraction of observations that we get from INRIX compared to estimated daily average volume in New York, which is shown on the right. Now let's go back to the cameras. So I said cameras provide an accurate count but are sparsely available. However, they could be used to calibrate a system of traffic flow for the whole city. If we can simulate the whole city as a physical system accurately, then we can use cameras to reconstruct available traffic everywhere. On the left here, you can see a beautiful rendering of New York. Beautiful because I spent a day making sure this renders on the web. And on the right is a more practical view of New York as a network, which is what we look at when we are debugging models. We use this network and estimate how vehicles move through the system, how congestion is created, and how it dissipates, which allows us to understand what we refer to as the heartbeat of the city, thumping during the morning rush and during the evening rush once per day. Unfortunately, videos aren't playing, so I won't be able to show you this really nice video of traffic flowing through the city. But I am happy to show you later. Now, after we build a network model of the city, this model now needs to be calibrated. We can use an ensemble Kalman filter to calibrate this model and obtain calibrated traffic flow. What you can see here on the bottom left is what counts look like that we would get in raw data collected from GPS sources. And on the top left here, you can see what our cameras see, and we can use that ground truth from the cameras to actually see the actual amount of traffic flow across the city. Now, what's important to notice here is that by calibrating our model of traffic flow across New York using this video data, we can get accurate results in regards to the actual traffic flow in the city in areas around the city for which we don't have camera data for ground truth calibration. Here are two examples from the area, from this area around Harlem and Morningside Heights, in which you can see that our models actually are able to accurately reconstruct the volume that we would observe from these cameras, simply using a sparse subset of the cameras for calibration. This is what it looks like. What you see on the left here is the raw data that we get from GPS sources, and after calibration, you can see that the traffic flow looks quite different. What this enables us to do is to accurately observe the traffic flow in the city throughout these areas. Now, why do we care about this? This fixes the data that we observe and allows us to see the true behavior and state of the traffic, enabling more intelligent and efficient vehicle-to-vehicle communication, route estimation, and modeling of the effects of different types of interventions on citywide scale and large range or urban planning decisions. In fact, to give a very concrete example, this could allow us to avoid traffic jams in lower Manhattan that last for hours, where everyone is routed through small side streets, for example, that cause jams. And I am sure that everyone who has been in this city has eventually experienced this problem when they were trying to travel upstate or trying to go to the airport, and etc. Finally, I want to thank our research team for this project, and I want to also highlight our collaborators on the congestion pricing project as well. We have a poster during the poster session where we will be happy to talk about these projects, and hopefully I will be able to play the videos. They are very impressive, I assure you. And some of our research team will be around as well. Thank you so much for listening.
Okay, thank you so much, Mehmet, for that presentation. I think you all hear the enthusiasm from our research team because this is pretty novel for us to gain these types of data that we can fuse and create new types of traffic models that are much more accurate, much more real time than anything anyone's ever produced so far. But I want to turn it over to you, Rob, since your job is to make things move faster in city government. From your perspective, what does it do to have a real-time traffic model that is actually calibrated and you can trust? What do you see the potential in terms of how government moves to deliver on its big promises?
This discussion and topic brings up strong feelings in me. I'm verklempt. Speaking to Kristen, we really do need to start with the why, to sort of do the storytelling on what is the application of that technology. And I want everyone in the room to understand your normal interaction with this data, route finding, avoiding the traffic. This morning, I used Google products to figure out whether I needed to take a bus or a train to get here. Turns out the bus was faster. It was actually, it said 45 minutes and it took me 35 minutes. So maybe if you could clarify that data when you get back to your desk. Is what most people interact with this data for. That is not what government needs or uses. It is much more foundational to everyone's life than you know. The next level of obvious things are how we operate our public realm. So bike lanes, bus lanes, daylighting, which for those of you not in the city means we pull back the street side parking to allow more pedestrian crossings in safer turning radiuses. So the public lives are saved by this information. All of that is informed by how we predict the future of traffic. And we need to have some baseline data in order to make those future predictions. At an even more fundamental level, we're talking a little bit about the abundance agenda and how we deliver change in our cities. Our housing is frictioned and limited. Our housing production, our housing crisis is frictioned by how we plan growth in our urban environments. If you're not familiar with environmental review, it drives almost all of our long-term planning projects. It is a very political conversation about how housing interacts with traffic because most people care about traffic very, very much when they are considering new neighbors or not. So how we project those future conditions is very much a political conversation we have that enables us to fix those abundance agenda items that we are called to do. And I really wish Ezra Klein would write the next book, which doesn't just tell the story, but actually tells me how to do my job. But that's what we're here to do, is get in the weeds, talk about how, okay, we have a general, we've inherited a lot of bureaucracy from our from generations past. The current technology, we can go into this a while, is very dumb, to put it simply. And we have to use these systems in order to make plans for our future, in order to deliver the things. I do want to reframe, and I think we should spend some time talking about this, and I'm really interested in INRIX's position, reframe the comment about trust, and I would prefer to use the word confidence. It's a very important distinction. From government perspective, we both produce and consume this data. However, we are accountable to a very wide variety of opinions. For those of you who live in New York City, you may know New Yorkers cannot agree on anything. So something like whether there should be a bike lane in my neighborhood or not is very, very difficult and controversial. And we have to have a level of confidence when we speak to all of those stakeholders in a way that we can defend. So I know it feels like we have too many lawyers, which I absolutely agree we do. And they are 100% my nightmare. But they are not wrong that they are there to protect me from litigation. We are a nation of laws, and every citizen has a right to appeal to our regulatory environment. So we talk about confidence, we talk about sort of the regulatory grade of data, and being close is not good enough. And so that's another thing I want to frame in this conversation. And that's why we really need to lean in this technology and sort of understand how can we get that validation level for these data sources that are reliable. Okay.
That's great. So Ahmed, I want to talk to you not just because of INRIX, but you have a background in city DOTs, right? So I'm thinking if you could sort of wear both hats and think about from a city perspective, but also understanding what you know now about so many cities in your role in INRIX, what do you think that this might unlock in cities outside of New York?
Yeah, for sure. Similar to Kristen, I'm not a recovering lawyer, but I'm a recovering traffic engineer. And so I worked for the city of Seattle for 10 years, specifically in operations. So, you know, I ran the traffic signal system there. I ran the ITS system in Seattle. And like New York City is, you know, quite a bit older than Seattle is, but also, you know, from a technological perspective, pretty old, very well built out city, mature city. And, you know, the systems that are in place in cities like Seattle, like New York City, you know, many other places around the country are pretty archaic. And so for our system in Seattle, we used to run in our downtown areas, we would just run a fixed time system, right? So that doesn't mean that you know, once you have a mature city that's fully built out, the only way you can control it is with traffic signals, right? You have more people on the street that want to move than you have space to move them. And so you have to put traffic signals in to regulate how people move back and forth. And so the fixed time system in a lot of these cities, I mean, here in New York City, it's, you know, if you walk up really close to a traffic signal every once in a while, you might hear like a little bit of a ticking going on. You know, a lot of the system here is like electromechanical. Like it's actually running on a timer like you would have at, like, you know, when you're cooking dinner. And so having something that is flexible in real time that gives you, to Robert's point, you know, a level of confidence that you know what's going on in real time out in the street helps you manage that system a little better. So when I talk about a fixed time system, it's not like our traffic signals are running on the same timing all of the time. It's just each part of the day has just a fixed system. There's no sensors in place. There's, you know, you don't have enough money to build out. I think in New York City, you have like something like 5,000 traffic signals.
12,000 signals, 60,000 intersections.
12,000. Okay, 12,000 signals. So you have 12,000 signals. If you think about outfitting each one of them with sensors, each sensor costs about $5,000 to $10,000. You know, just do the math there. You're talking about billions of dollars to run, you know, sensors on every single intersection. And so that's just not a plausible solution for this problem. And even if you are running sensors in those locations, you're basically using 1980s technology to build you know, a 2020s solution. And so what Mehmet showed there on the you know, in his project is, you know, with the technology and the data that's available today, you can build a system in real time that gives you a certain degree of confidence to at least begin shifting how you look at things. So, you know, again, going back to that Seattle solution that I was talking about, we would switch at about 9:30, 10 a.m. We would switch from our morning plan to our midday plan. But if traffic's really bad, you don't know if it's at 10:05, is it still during morning peak or not, right? At 10:25, are you still in the peak or not? You might have an incident that happens on the freeway, or, you know, some major construction that's happening on the transit system where the peaks start to extend further and further, and all you end up with is just worse and worse and worse traffic throughout the day. You know, the midday, you know, creeps into the afternoon, and really you're just left with a mess for the entire day. So a system like this can help you to respond in real time, pull your plans together, and really, you know, what I equate it to is, you know, if you think about, you know, going from writing letters to dial-up to high-speed internet to 5G, right, is having a solution like this can get you from writing letters, maybe even dial-up, to jumping past that generation into something that's much more like 5G, where I don't have to deploy hardware everywhere. It's not that there's no hardware in that system. There's a lot of hardware in that system. There's a lot of cameras going on there. But you just don't have to deploy those cameras and that hardware at every single location.
So I want to get back to the data question. So you mentioned there's all this data, right? And now we're developing the methods to fuse it and actually understand in real time what's happening and be able to respond. But that data doesn't come from one source. We're pulling data from public cameras that are installed at varying qualities, right, at varying reliability rates. We're pulling data from INRIX, private data, right? There's other data sources we might want to pull from to improve these and to actually make these operational. So when it comes to working with private sector, when it comes to working with public sector and trying to fuse these data sources and create a single framework that we can advance through research like this, what are the main barriers to moving this forward, just in that data question?
So let's be a little sharpen our pencils on what we mean by traffic data, because it is pertinent to our confidence. So the gold standard, and this comes from probably Eisenhower-era ITE traffic engineering manuals, is volume to capacity modeling. So we really need to understand the volume of traffic that is going through an intersection that's turning left, that's turning right in each individual lane in all directions, right? So that is a very high standard. We also need a classification of those vehicles, whether they are trucks, cars, bikes, PEDs, and then there's a level of delay that is also informed. If an intersection is backed up, you get less volume because cars are waiting to go through, and that sort of informs. I also want to add, into my why story, New York City is a non-attainment area for national air quality standards. So when we talk about congestion, we're talking about asthma rates, and we're talking about very, very serious things. So understanding that truck traffic percentage is also really, really important to how we do our modeling, and was a big part of the congestion pricing conversation as well. Okay, so this is a very nuanced, detailed map, and you end up with sort of those volume maps where you see it spread across the city. Our current practices, the inputs that we use to collect these turning movement counts, we'll get to where the future is taking us, is not imperfect. So when I was a young student, we actually sat at the corner with the clicker and counted cars as they were going through and turning right and left. That has progressed now and was very flawed, because if you have two interns counting the same intersection, you get different numbers every time. So that is an understanding that there is a lower level of confidence there. Currently, there is now 360-degree video cameras that can be set up on a temporary basis for collecting data for a broad period. That video is then downloaded, and then the intern sits at their desk and does the clicking on the video, which is still pretty dumb. And you can still get different numbers from two different interns looking at two different videos. So there's still sort of a less imperfect confidence level there. There's also huge limitations on that. Obviously the cost of installing a camera and taking it out, you have to know which intersections you need the camera in before you actually do the counts. You can't look backwards at what happened 2 weeks ago because you have to have the camera in place before you do it. So you need to set up a program. You need a permit to put the camera up. And so, you get certainly like a month or two delay from when you need the data from when you actually have a table available. That's, a hugely far away from where we want to be. There's also things called tubes counters, automatic traffic counters. They put a pneumatic tube across that does not do very good at telling you whether the car is turning or not, does not do you any good to tell you whether it's a truck or a car. Right, so that is our basic system now. You want to talk a little bit about probe data?
Yeah, sure. I mean, essentially what INRIX does is we take GPS points from a number of different types of devices. So passenger vehicles, freight vehicles, or cell phone data, right? And if you think of it just as a breadcrumb, you get a GPS point every, so often, some from like 3 to 30 seconds from each of these devices. And if you take those and stitch them together, you understand, where people are moving, right? And so essentially what we do, and you saw in Mehmet's little GIF there, is like we have a pretty small percentage of the total number of vehicles. It depends on exactly what you're counting. It can be, I think I saw on there from anywhere from 20 to 40% of the vehicles that are on the road to like 1 to 2%. of the vehicles that are on the road. So you have a small sliver, but instead of, like Robert was saying, tracking something for a week or a day or a month, you're tracking it all the time. And rather than tracking it in one place, you're tracking it everywhere, right? So there's no real, geographic limitation, and there's no temporal limitation on what you're looking at. So it is just a different way to look at confidence, right? So tracking very little things, everywhere all the time, or I'm tracking in a few key locations everything for a short period of time, right? Or if you're using the cameras like what Mehmet's doing, right? You're tracking in those small places everything all the time, but you have a pretty high confidence interval, somewhere probably in like the high 90s in those locations, right? And so it's really an apples to oranges comparison as far as like, what you're trying to achieve. For some things it's really good, for some things it's not so good. But I think a little bit of what kind of the project is trying to show here is that a hybrid of the two is actually probably the best solution, because you get the best of both worlds in that instance.
And that's the vision, that's the hope, is that we can produce a real-time live model based on a network of sampled computer vision that can give instant data feeds with all of these classifications. They're pretty good at telling the difference between a car and a truck, with identifying the actual path. That somehow magically gets fed into some magic over there that I don't understand, and then gives us a either real-time digital twin or some sort of summarized volume map of the city. There is a lot of massaging that comes in to any of these sort of data treatments, and we need smart academics to help us with that language learning, neural net learning, to do that massaging work, because we get a validation point at one intersection, and then you have 4 more intersections before you get the next validation point, and people are turning and going into driveways and McDonald's or whatever in the middle. And so we need to be able to use those 2 validation points in a way that is balanced, and that's where the rubber really meets the road.
Exactly, and that's kind of where I put the plug in. I mean, Mehmet mentioned it a couple of times, is what we're trying to do. So part of this was part of a program that INRIX runs called the INRIX Metro Lab Challenge, where we work with academics and we just give away our data for free to the academics so that they can try new and interesting things, right? And I was thinking about it. I was sitting upstairs, like in the green room, and Robert walked in. Mehmet was already there, and you could probably just like blindly do a view of this. If I said one was an academic, one was a city administrator, and one person worked at a tech company, you'd probably be like, oh, just by the way these guys are dressed, I can pick out which one is which.
I'm not sure how I feel about that.
You're dressed very nicely. I'm the one that's a little bit. But the and it's also like the beginning of a joke, like 3 guys walk into a bar and, all that type of stuff. But really the way that we look at it is, we make our data available, but that massaging piece that Robert talked about, I'm not in the position to massage data in New York City. I mean, you brought this up very quickly. I forgot what your name was. Yes. Leanne, right? She knows locally what's happening in Tampa. I have no idea locally what's happening in Tampa. All I can do is look at the data, I can produce a model, and I can output something that I think is relatively accurate for what's happening in that location to a certain degree of confidence. But folks that actually have the local knowledge there to kind of like guide the vision, what Robert's team is doing, and then people at Columbia that, again, live here locally, and when you talk about like what's going on in the back with like the machine learning models and all of that stuff, like, Mehmet can talk about that for days. He used a bunch of words up there I've never heard of. And that's really what we're trying to encourage more than anything, is like our job is just to build stuff at scale, right? We're trying to build stuff worldwide all of the time. And how that gets implemented locally, we leave that up to the people that are buying our data locally, right? And partnerships like this with the academic community really helps us to kind of like push that boundary of what the art of the possible is, and then other cities and other locations and other universities can learn from that, and it really starts to impact how people deploy locally for their local problems?
Let me speak about partnership as well. I think that's really important in this room. We recognize that there's a role that the commercial industry plays with our ability to govern, and it is, yes, we need to be cautious and worry about capture. If you guys have not read Recoding America, I definitely recommend that. It's very relevant to this conversation. But there does need to be opportunities for investment in ways that produce returns. We understand that. I will say my experience in the past couple of years on this particular question has been very, very frustrating. It's very hard to create a innovative startup in a world where you more or less have one or two customers that are meaningfully buying at scale for technology. We not only consume the data, but we are also owners of the public realm. So we have to be the one to purchase and or allow for the deployment of these things. And so, I'm just very sympathetic to that. That's an impossible business model to try to predict investments in technology that may or may not be captured. And currently, if everyone has not noticed, the funding process between the federal government and the local governments is incredibly unpredictable. We have made some efforts in trying to deploy technology that would be beneficial to the conversation, but without having any sort of confidence. We have a multiple-year procurement process. Even though we have innovative models here in New York City, it still takes us too long. And if we cannot have a predictable income streams in order to do that, we cannot help the startups build the things that we need to use to provide our citizens meaningful data, meaningful housing. So Google, if you can do anything about the federal government right now, that would be great.
I will say that this is one thing where academia has an advantage, where we are ideally positioned for this type of thing as well. Sure, perhaps it's hard for startups, but that's what we are here for to some extent, to be able to combine these sources of data, build cutting-edge models, and hopefully eventually deploy them.
Yeah. We also recognize buying a bunch of computer vision cameras that work in New York City makes it really hard for INRIX to have a product that is national, that is usable, right? That works for us, and we may be a big enough customer that matters to them, but we don't want to. Well, let me say, I'm obligated to say New York City is the best country in the world every time I show up in the public, which is true. But it makes it hard for them to build a product for everybody.
I think you just seceded right there, best country in the world. But yes, it absolutely is the best city in the country, best city in the world.
City in the country is what I was going for.
Okay.
But I'll go with world too.
Yeah, I'll go with world too.
So we have about 14 minutes left. I want to leave 10 minutes for questions. So in the last 4 minutes then of the panel discussion, can you talk about sort of concrete next steps that you see us taking together to help bring this to the next level, take steps towards scaling, towards actually deployment in New York City and hopefully in other places? I know this exact model might not work in other cities, but the methods we used to develop the model should apply to other places. So what do you see as the next steps to validating this in New York City, scaling it, deploying it, testing it, perhaps getting regulatory approval and buy-in in this process? How do you see us moving in that direction?
Yeah, so I think the question that we've posed to academia is how many validation points do we need in this citywide model? If we have 12,000 intersections, do we need to buy 6,000 cameras? Do we need to buy, and cameras is not the right word, they're not actually cameras. We can talk a little bit about what that computer vision technology does and doesn't do. Can we use our existing cameras with some software add-on? So those are questions that we need to understand the statistical science and data science behind in order for us to sort of produce a procurement plan. Can we do, is it one neighborhood at a time sufficient? All of these things are really critical in how we deploy government, and we're hoping to see that. I would say that's the low lift. There's a high lift idea, which is rather than using these sort of Eisenhower era VC ratio analysis for traffic modeling, is there more innovative ways to totally move the federal government in how they understand congestion and traffic and what's important in cities that gets away from sort of the highway-based lane turning movement count analysis, which I think is more interesting, and we need a lot more assistance with how to move the federal conversation along.
Yeah, I mean, I think from our end, one of the key elements. I mean, we heard Andrew and Kristen both talk about AI models, and I think Robert kind of alluding to it there at the end of using different type of modeling techniques. I mean, for us, the number one thing is how we avoid the garbage in, garbage out situation, right? And so there's a pretty significant difference, especially in New York City, right? Like, it is definitely on the U.S. side of things the most unique place for INRIX, just because there's no place really that has the same type of urban canyons for GPS like New York City. So it starts for us really almost at the sensor level. Like, we don't own sensors, but we procure data from people, and so things like cell phone data does not work very good here, right? It just doesn't. It's a limitation of the actual sensor on your phone versus the sensor in a vehicle or in a fleet telematics device. There is a limitation there, and so having that really good sensor that leads to really good data that then leads to a really good model. That's ultimately from our perspective where a lot of our focus is on is, we're trying to build confidence in the data that we have and in what people can do with the data that we have, what we can do ourselves with the data that we have. But ultimately it starts at that base level. And then, even some of the, extrapolating on to like some of the next steps, especially with what Robert's talking about, is like going out and you have to prove at scale with ground truth data that your model is actually producing the result that you think it is. So not just in those locations where we have those permanent cameras, but in locations where you don't have permanent cameras, are you still getting the result from the model that is close enough to what's actually happening in the real world, and then comparing it to those Eisenhower level models of saying, okay, was this result closer or this result closer to what we actually saw out there? And then, having that at enough scale where you can, really have the confidence to make that shift.
Mehmet, do you have any thoughts?
Oh, yeah. I would say from our end, of course, this is a project that's in an early stage, but our results, especially the ones I've shown for the whole of Manhattan, as well as those that focus completely on the Harlem and Morningside Heights area with only about 10 cameras, do already show really good results with R-squared throughout the city having an average of 0.5, which is really good, by the way, for these types of models. And on top of it, we can calibrate with camera count data. One big issue we have today is that we don't have as academia, have access to high-resolution camera feeds from even the existing cameras. For example, if we had those, then we could, I think, show over these 900 camera sets that that set is enough, hopefully, with high level of confidence to reconstruct traffic throughout New York. And moving onwards, of course, we can have more cameras, other types of sensors. But I think our models show promise, but we do need access to sources of data that we do not have today. One small thing I will add on top is that one thing that's not always seen is that in academia, especially for publishing in highest tier conferences, which I'm sure many here know about, we actually also need to be able to publish the data sets that we are using. Because we cannot do that for some specific projects, not thankfully for this one. We cannot even afford to annotate the data that we have. So I'd say these are big problems.
And let me dive in a little bit on, kind of feel bad. That comment was clearly pointed at me. Why can't you to open up the books? Let's talk a little bit about that confidentiality and privacy issues. We don't provide access to the high resolution cameras for just that reason, is we do not want license plates being able to be read by the public as people are traveling around. One occasion of a domestic violence person using that information would be tragic, and I just don't want to even think about that. So we do have some very low resolution a lot of very low resolution cameras that provide, you cannot distinguish faces, you cannot distinguish license plates, that we make accessible to academics and different people. The technology that we're really interested in so there's sort of like one set of startups who are working on software solutions using those cameras that are trying to get accurate enough. There's another that is a hardware solution that has edge processing, where you have a sensor attached to a network device. We have them, 12,000 of them, that is feeding live data in 15 minutes, but it does not preserve the image. It only gives you tabulated data on left-right turns and classifications. So that solves some of that security concerns, but then we don't have the video to validate against, so we have to be really, really confident that we're getting 99% accuracy on those classifications on one instrument, and so that we can buy a lot more of them. In a couple of minutes left, I'll tell you a fun story. I was working on our Blue Highway initiative, which is a government effort to move a lot of our freight off of our truck systems into our rivers, because New York City has a huge history and access to rivers. And one of the ideas that we were excited about was last mile delivery through freight bikes, which are if you guys haven't seen them because you're not from our town, we have them here in New York City. Amazon uses them. They're like, I don't know, 3 feet by 6 feet boxes with pedals, 4 wheels, and a battery assist. And they use them so that they don't have to take up the parking lane to deliver and avoids parking tickets. They're not allowed in the bike lanes. They are required to go on the street. So I had to do the fun of how do we model volumes of freight bikes coming out of a new freight facility into our network, and what is the traffic impact that it has on the community. And so we had to argue about how much of a car is one freight bike, and we ended up with like 0.8 of a car was the answer, because we had to model how many bikes are going out, turning left in this place, which is like when you get in, like, why is government so slow in adoption? We now have to have a edge processing system that can acknowledge that this is only 0.8 of a car, not one car, and that requires another learning round and new stuff. So that was a fun story. Thanks.
Okay, so I want to make sure we have some time for questions. We have about 5 minutes. So I don't know if anyone has any questions or... Yes. I don't know. Do you want to... Is that okay going over the mic over there so everyone can hear it? Thank you. I would say anyone else with a question, if you want to line up behind a mic, then we can get to you. Thank you.
Yeah, my quick question is on the procurement side of all of this. So I was wondering maybe what would you change to make that from pilot, getting that early validation, to then actually securing a government procurement? What's that process like from each of your perspectives, and what is maybe one lesson you would tell an early startup to start preparing for if they're looking to target one of those like big government procurements?
Maybe that's me. Shoot. Well, first of all, I would not preview a procurement, because that would be problematic to benefit people in the room and not people outside the room. It is complicated and difficult, and I'm not sure that I can tell you. And as I raised earlier, like we recognize it is very hard without sort of a pipeline to work on. We do these things. There are some new, more innovative approaches. Challenge-based procurement is a way that we can sort of start a broad range of issue a challenge and say, like, how do you deploy technology that fixes this solution? Frankly, I just don't have the money right now to even start that process. We are in the middle of a budget cycle. We are trying to see like what we can do next. But we need to size that program, because our budget offices needs to understand, are we looking at, and I'm sorry, it's not $5,000 a camera, it's more than that. Are we looking at 1,000 cameras, or are we looking at 20? And part of our side is like, can we do more piloting program? Like I said, one neighborhood at a time, with the plan that we need to figure out the data sharing environment. That is a whole nother piece of our procurement, is having a data portal that is accessible by industry and the public, if you want to do your own GIS work. So that is a non-answer on purpose, but saying like, yes, I need, or if there are other donors in the audience who are looking to find a socially responsible place.
You'll do it quick, and then we'll go to the side of the room.
Yeah, I mean, I'll just put a plug in for cooperative procurement. We participate in numerous cooperative procurement vehicles, and it's it's not non-competitive. Those are competitive procurements. They're just done by multiple agencies at once. And it gives you like a little bit of a menu to choose from.
And before I leave here, I want to say, I know other municipalities use INRIX products in applications that we don't, because of our confidence issues and our belief that we are unique. So it is not, there are applications where they're appropriate, and we're not arguing that.
Totally.
Yeah.
Okay, we're going to go this side.
Thank you. This is wonderful. My name is Florence Hudson, and I'm in the Data Science Institute here at Columbia. And I'm Executive Director for the Big Data Innovation Hub, funded by NSF, DOT, FHWA, ooh, this is where I'm going, NIH and DARPA. And we did a transportation data science project for DOT. They said, we want to teach people how to use data science tools and techniques. Gotcha. And so we had... we created a hands-on project, asynchronous. We had 5,000 people participate, gave over like 500 certificates out. And as I listened to you, I'm thinking, wow, so I'm like a new friend for all of you. I haven't really been in this. But I'm on the side doing this, and I bet you a lot of us are doing different things, and it would be so cool to figure out how to connect us more. I'm so fortunate that I was able to come today, and I want to thank you for inviting me. I'm interested in how we can play together more, what the ecosystem is or the community is. And then, as you were saying, we really need to get the federal level to help us, and highways are highways, and there's highways in New York City, but other things in New York City, we use the NYC Open data, crashes and collisions data set. And I'm thinking, how can we do more together? How can we help more? So that's my question.
Yeah, and that's absolutely yes, and
Okay.
the other answer to how can we work together is educating civil servants is incredibly important, myself candidly included, but building confidence requires some deep knowledge that you seem to have and you have that we don't. It does require me to take time out of their day, at least 10% or whatever you want to call it, in order for us to either come to you or you to come to us, in order to us to explain what a neural net is, which I still haven't figured out. So that...
That's okay.
Is an incredibly important piece, and we want to work with you.
Yeah, I'd love to connect because we have free open online data science projects, asynchronous, you get a Google Colab notebook. And interestingly, we created it kind of for students, but we found professionals participating, and they told us, don't tell the DOT we did this. Because,
Okay, come on, guys.
well, no, they don't want people to know they don't know it, and it's not fair. Like if you're a student, you're walking around going, oh, look at this new class on ML, I think I'll take it. You don't have time for that. So we can help, and there are cute little things we can do, so I'm going to connect with you. Thanks.
Okay, we have time for one more very quick question.
I'll be quick.
Okay.
My name's Kavish. I'm a computer science and finance student, so this is very new for me, right? But it's interesting. So my question, it's reasonably simple. It's for Robert. You mentioned that these sensors have, they're very low quality, the ones that you're given to the researchers. So how do you keep those low quality sensors from ruining maybe your advanced AI models that the researchers are working with?
I might need some help on that. It's
Yeah.
not that the quality is...
They are really low resolution. I can tell you, if you look at our webpage for the congestion pricing project, we actually trained special models that perform well on that low resolution footage so that we could perform this congestion pricing project, as well as this INRIX Plus MetroLab project in order to calibrate our network model.
I would say low quality, you get enough resolution to tell that it is a truck or it is a car and it is turning left, because that is not a resolution issue. We get in more trouble when we are looking at cell phone data. And I'm carrying 2 cell phones right now. And so trying to be able to pull those apart and understand that as one user is where that resolution becomes more of a problem. But when we're looking at computer vision analytics, we're pretty good. We think we're in the 99%. The pedestrians are a little bit tougher, but that's not the problem. Right.
Thank you.
Okay, so that's time for us, but thank you so much to Mehmet, Robert, Ahmed. This was such a great discussion.